developers learn new frameworks and tools, things that make them productive at work. And also, to do this, we bring top speakers from the world of tech to introduce these new tools and frameworks to programmers. So today's webinar is led by Maciej Walkowiak. He joins us from Berlin, Germany. I hope that's correct.
It's still correct.
Okay. Yeah. So very quick introduction about Maciej. Maciej has been an independent software consultant for over a decade now, and he helps companies make these architectural decisions about what tools to use, how to build high performance systems and stuff like that. And he has previously worked on Sentry, and we did a webinar on Sentry in the past with Maciej, and where he was so good, and that was so well received, and we wanted to bring him back with another interesting topic. And today he will be talking about GraphQL. Maciej has been an open source enthusiast. He was the Spring Cloud AWS project lead, and also a very, very widely known contributor to several Spring projects. And then for most people, he is familiar because of his excellent YouTube channel, the Spring Academy channel, which has a lot of people learning Spring from, and it's been very popular for several years now. So today Maciej will be talking about GraphQL. That topic's been picking up in terms of popularity among developers. It's today seen as an alternative to REST APIs, and some teams it's become like the go-to choice for web and mobile backends. And this year, Spring added an official first-class support for developing GraphQL APIs with Spring for GraphQL. So in this session, we will start off with GraphQL. How does it compare with REST APIs, and how to implement GraphQL with Spring. Since most of you come from the Java Spring Boot experience, we hope that the session will be very, very useful to you. So Maciej, thanks for taking the time out to connect with us again. Great to have you back again.
Thanks a lot for a very nice introduction, and thank you, listeners, for coming to the let's say lecture. But I wouldn't like to make it really as a lecture. I would like to make it a little bit more interactive. So just in case you have any question, feel free to ask in the chat, and someone will read it out loud to me. I will try to answer, but if I don't manage to answer, if I don't have an answer, then at least it's a learning for me. So we are going to talk about GraphQL, and specifically about Spring GraphQL, because this year is finally the time when Spring added official support for GraphQL. Before, there were many third-party projects and many attempts to integrate GraphQL Java library into Spring ecosystem. But as always, when you integrate some third-party library, it's a kind of risk. So having a first-class support definitely is a game changer whenever you are in charge of choosing the technology you want to implement your applications with. And when we speak about GraphQL, I think it's really good to think, why do we even talk about it? And assuming you are not in a business as long as I am, I will give you a very short introduction, very short part of the history, how this whole web development with Java and Spring, specifically for web and enterprise application, evolves over a couple of years. And I will just keep the frame of the years where I had actual production experience. So more or less before 2010, the web applications all look like this. We had a web application that was a WAR file deployed to Tomcat. There was some database, and then there was a browser. And this web application was basically reacting to HTTP requests and rendering HTML. And this was pretty much it. This was maintained by the full stack development team. So we had people who were actually considered full stack, even though this term did not exist back then. They were doing both front end and back end. And there was no API. If you worked in, let's say, a little bit more enterprise setup and you had to develop APIs, this was usually your application talking to some other applications over SOAP. SOAP is a protocol that very likely you have not worked with, and this means you can consider yourself lucky, because this wasn't really a very developer-friendly experience, and it was causing a lot of troubles. But still, the front end was just the HTML website. And then things started to change more or less after 2007. So when iPhone got released and when smartphones started to pick up, then we didn't have only the web browser as a client, but also mobile clients. And these mobile clients were, of course, the fat applications, meaning that there were like applications installed on a mobile app. And then suddenly the HTML response format was not something that they were really interested in, but they wanted to get some data over an API. So we were just creating these HTTP APIs that returned usually JSON, because this is still like the most developer friendly and also quite good format to transfer objects just in general. So we just had an API and then HTML website. Things got even more tricky after 2011, or when AngularJS was released, because this was the moment when we started to separate front-end from back-end in the browser. And we started to have dedicated front-end teams for building web front-ends. These were usually single-page applications, no matter if it was Angular or React. And all the communication between front-end and back-end started to rely only on JSON sent over HTTP. Often we called it REST APIs, despite that it didn't necessarily had much to do with actual REST API by a definition. But the key point is that now we don't serve HTML pages, we just serve JSON over HTTP, and we have different clients that also have slightly different needs. So when you think about any website, it's usually packed with information, mainly because we have big screens. As long as you browse it on the desktop, right? So it has a big screen. Mobile, on the other hand, is small screen. It also, for mobile, is critical that the communication is fast, right? So that we don't transfer more data than we actually need, because the response time is very critical on mobile. So just to give you an example, for example, when you have a website running on the desktop, when we get books, we are interested in more data than we are interested in the mobile. So we not only get like the book title or publication year, but we also need to get a description that potentially is a large blob of text. If this text is not used on the mobile app, then we have this data is just sent without a really good reason. And this is something that it's called overfetching. So it means that when we are on mobile, or rather like the mobile client fetches more data than it actually needs, and this potentially slows down. Sorry, my cat wants to come in from the terrace. I need to let him in because I can't focus. Moment. So this is one of the issues that we faced when developing like a traditional RESTful APIs. Then another problem is data composition. So just to give you this example, we would have two endpoints. One returns books, and another endpoint returns authors for these books, but we can fetch the author by ID. So when we fetch the list of books, each book has an author ID. And then for each of this book, if we want to display an author information on the website or in the mobile app, it doesn't really matter in this case. For each book, we would have to make an additional request to the backend. So rendering one single page could result in multiple requests depending on how many books are going to be displayed. Then we have to make the same number of requests for each author. And of course, this could be modeled differently, but this is very realistic example of the APIs you have to deal with when you are building a front end So I'm saying this from the front-end developer point of view. And there are more problems with REST APIs. I mean, first of all, we often say that REST API, but actually REST is more like an architecture style that doesn't really have a spec. It has just a list of principles. So whenever we develop a REST API, what it often happens that someone will tell you that, well, oh, this is actually not a REST API because you didn't match one of the principles or the preconditions that someone thinks that this actually makes an API a REST API. So it is really difficult to get it right. And this is quite frustrating also from the front-end development point of view, because for every API, you have to pretty much learn how to use this API, and it's not very clear. Often it's also not really documented. Then we have these two problems that I mentioned before, so overfetching and expensive data composition. One, expensive from the point of view that there are a lot of requests sent to the backend, but also another problem is that it's a lot of code on the client side to write it. And of course, writing code means potential problems. Another thing is that there is no schema often. And the proper REST API has something that is called hypermedia, which means that each resource is linked to another, potentially is linked to another resources. And first of all, most APIs don't even develop it. And even if backend developers decide to develop hypermedia, this is usually not what front-end developers want and need, and this is causing probably more frustration. And just to make it clear, I'm not really criticizing REST here. It's more like a critique of the APIs that call themselves REST, even though they are not really REST. So these are like a typical JSON over HTTP APIs. And most of this problem has already been solved also when you develop REST APIs. One thing is called OpenAPI, where it defines how you can create a schema for your REST APIs. And also there is JSON API that defines how to use the hypermedia in a standard format, which has a spec. So all these problems are possible to solve when developing REST. So just to make it clear, this is not bashing REST. It's more like showing like the problems that led to creating GraphQL. Enough about REST. We switch now to the GraphQL. When you start working with GraphQL, first of all, you have to forget everything you know about REST, about REST principles. When I mean this, like HTTP method format, HTTP methods, the URIs, so the things that we always learn, like this, it must be done to call it a REST API. It doesn't really matter. Status codes doesn't matter at all. The way you did, let's say, caching with HTTP also does not apply. So in case of GraphQL, HTTP actually became only a transport protocol just because this is what is supported in the browser. If there could be, like, you can also use actually GraphQL over WebSockets, but since HTTP is quite easy and it's also pretty good, then the default way to use GraphQL is just to use it over HTTP. And GraphQL itself also is not really even an API, but it's more like a query language for your API. You can see the definition over here. This is really copy-pasted from GraphQL website. You can read it later. But in practice, it means, this is like the one slide that shows basically most of the things that you have to know to really get like to understand what is GraphQL. So first we define a schema, which really defines what methods are available in the API, what is the structure of the types that we use in these methods. Then, and this schema is known both for the backend and the client. And then from the client side, you send a query, and this query looks exactly like this. So you basically create this string and send it over HTTP to the backend. So you define which query you want to run, and then which fields are you interested in from the result type that this query returns. And then you get a JSON with a result. So this solves already these two problems that I mentioned before. Like first one is overfetching, because you can just specify the fields that you need, and also the composition, because the schema defines how this data is linked and composed to each other. And from the client side, you just say like what you want in a very declarative way, and then it's a job of the backend to make it happen. Do we have any questions so far?
None much. So I think we can go ahead.
Okay, good. So I mean, I hope this means that it was understandable. And now I would like to show you just how to use GraphQL with Spring for GraphQL, and how to turn your kind of like a REST application into a GraphQL application, because I think that Spring for GraphQL did, like, folks behind the Spring for GraphQL did a really great job in making this feel very springy, meaning that like they provided like really springy programming model for GraphQL. So our starting point is like a regular REST application, REST-ish, let's say, application, where we have two entities. One is the author, which could, of course, write multiple books. And then we have a book, and then has just a couple of fields like ID, title, publication year, and also an author field. These are all mapped with JPA, so they are persisted in the database. For each one of them, we have a regular Spring data repository that just extends CRUD repository, so there's nothing really surprising here. And then we have a controller that just returns a list of books. And then at the start of the application, I'm just saving 2 authors and 2 books just to have some data to work on. So now when I run this application, and I will use my custom Maven plugin just to run it so that it refreshes for me without having to restart it, just so that it goes much smoother. So now when I started this application, I should be able to hit it with HTTP and the endpoint books, and then it should return these 2 books. So it means that everything works as expected. So now let's turn into a Spring for GraphQL. So first of all, we have to add a Spring Boot starter for GraphQL, like for any other starter dependency, and create a directory in source main resources that is called GraphQL. And inside this GraphQL has to be a file called schema GraphQLs, which stands for GraphQL schema. Okay. And now this is where we define what is available on our backend. And this is also something that the frontend will be aware of. At the root, we have to define a type query. This is by convention. And here we can define methods. So I can say that it will be possible to fetch books, and this will return an array or a list of an input type, of an object called books. So now we define the type book, and it has an ID. ID is like a special identifier in GraphQL schema that defines that this is going to be an ID. And the exclamation mark means that this field is required, so it's always there. So we have some like a basic type of even validation in the GraphQL schema, and this validation can be also extended to some really like sophisticated conditions. So then we have a string, and then we have a publication year, and this will be an int, and let's make it not really required. So now I saved it, so the application should already restart. But the one thing that I will also add is something that is called GraphQL, And GraphQL is a development console for GraphQL so that it's easier to just play with your API. So you can think about it like if you know Swagger, so this is kind of like a Swagger console, but for GraphQL. So now if I go to localhost 8080 GraphQL, let's ignore this. It loads an interface that is really great. And this you can find it pretty much for every GraphQL API you have, where you can just play with your API. So when we start with query, because it also matches our root of our schema, and then I hit Control space, then it auto completes what can I do with this API. So I can say that I want to fetch books, and I'm interested, let's say, only in ID and the title. So now if I execute it, of course, I will get nothing because I have not really developed any backend yet to fetch it, and it's not that smart to figure it out. So let me go back to the book controller, and I will remove this method because we don't really need it anymore. And I will also remove the book DTO because you will see that we also don't need it at all. And now let's create a method that will return an iterable of books, and this will return book repository find all. And then there is a new annotation that is called query mapping, and we don't need to actually provide anything else. I'm not sure if this will work with REST controller. I know that it's enough to annotate your GraphQL controllers with just a regular controller. Probably REST controller will not hurt, but let's do it properly. So now we annotated with a query mapping, and what's important is the method name. So this method name has to match what we have defined here in the type query, because this is how Spring basically glues the query together with the controller methods. If this method name is different, we can also define the name over here in the query annotation. So we could say books, and then this could be called whatever different. But let's stick to convention and run it like that. So the application should, did it restart? Maybe it didn't restart. So let me stop it. Okay, so the application is up. Whoops, what have I done? So now if I run it again, I will get a list of books as expected. And this is really wonderful because how easy it is. So now let's make it a little bit more realistic, and also let's show the advantages of using GraphQL over REST, because right now this is just a different way to fetch something that we have already had. So now let's create a book, a new type called author, and this has what fields does it have? It definitely has an ID, and let me get back to the author entity and see. This has also a name. And also it has a collection of books. So let's do name string. And also it has books, and this will be a list of books. Okay, so the application is restarted. Let me go back here. I will refresh the page. Now if I hit, oh, sorry, I have to also add it here. So that book has an author. Okay, so let's do it again. Now it should also auto-complete an author. So now in just one call, I can declaratively say that I want to fetch all the books, and I also want to have the books for this author. Because our author schema defines books over here, we can do something that is a little bit weird. So we can say that, okay, I also want, let's say, books for this authors, and then it fetches it like a, I mean, basically, this is a cascade, which is not necessarily something that you want to happen, because like if you define it too deep, then it can hurt your backend. Okay. So this is this looks a little bit magically because of how easy it is, but there is a little bit of hidden problem over here. If we enable logging for SQL, you will see that if we just fetch the book, there will be just a one SQL statement executed over here. So it selects the book, like all the fields about book from the book table. But if we include this outer over here, and then let me even remove this, then we will see that it's not only fetching a book, but first it fetches the book, but then for each book, it fetches this outer. So basically, we created for ourselves an n+1 problem, because it will, for each book, it will have to execute another SQL query. And this can dramatically decrease the performance of your backend. This is, of course, nothing new, because if you just build your REST APIs, you will end up with the same issues. So a typical way to solve it is to fetch the outers together with the books, right? So we will create a new method in the repository that will return a list of books, and let's call it find books with authors. And we have to make a special query for this that will be, and then we do join fetch the author. And then I think it's going to work. And then when we call the GraphQL method, we just use this instead. So now if I run this query again, we will get just a single query. So again, if you work with REST APIs and you have a little bit of experience with JPA, this is nothing new for you. The difference is, though, that now we ended up with a different problem. Like when we have this request to get books, and we just want to get the ID and title, we are not interested in anything else. From the client point of view, it gets only the information that it needs. So we can say that on the API level or the transfer level between the client and the server, this is efficient. But if we look in the log, we will see that, of course, always we fetch from the database more than we actually need. And fortunately, this can be also solved very nicely with GraphQL. So GraphQL, whenever we have this query mapping, we can access something that is called data fetching environment, which gives us information about the query that was sent to the backend. And here we can do that if the selection set, which means that the fields that were listed contain an author, then we want to return books with authors. And otherwise, we just want to return a books like we did before. So just to make sure that this is actually work as expected. So now I fetch only books without authors. There is a very simple query without any join. And now if I add an author over here, author, we can see that there is a different query returned. So with this, it's not only that it gives us, let's say, efficient data transfer between client and server, but now we can also fetch like the stuff that from the database that we only need. The thing that I miss that, of course, would be even nicer is that like if we specify ID and the title, or if we say, let's say, specify just an ID, it fetches from the database only ID, but at least by default, it will fetch all the data that are requested. Although when I think about it, probably it's also possible to be done with JPA. And our data model is relatively simple, right? We have a book and the author, so there is just one relation. you can imagine that if you have an entity that has many of this type of relations, you will have to create lots of different combinations of the query methods, and also this if statement will become way more complex. So we could say like, okay, if there is an author and another field, then run this query, and if this, and then another query, which is probably a valid way to solve it. But there are also other ways where Spring for GraphQL integrates with them very, very nicely. And this is called a query DSL. So query DSL is a Java DSL to send queries to the database. And there are different implementations. One is JPA, another one is, let's say, SQL, but there's also for MongoDB. And this is, again, a third-party project that is just, it's integrated with Spring Data JPA since ages, but it has like a dedicated support for Spring for GraphQL. Integrating query DSL, unfortunately, is a way too much code that I can remember. So let me just, what have I done? So let me just copy paste some part of dependencies. So we add the query DSL APT and query DSL JPA. And then we also need to add one more plugin. And now we can create, we can use the query DSL in a quite interesting way. So now let's go back to the book repository and make it extend not only CRUD repository, but also query DSL predicate executor, where these names are quite difficult to remember. And then we also have to annotate it with GraphQL repository. And now I can even get rid of this implementation over here. So basically, we don't even need this controller class at all. Just let me check. There's something wrong over here. And if I go to GraphQL, this should work exactly as before. So without even having any implementation. So let's look at the query. It executed simple select. Now, if I add a relation to author, it will return, it will execute the query with join. So query DSL and GraphQL integration just do everything behind the scene what I showed you before. Also, it has some nice feature, like we can create, let's say, a new method where we could say books by title. And this will be a title that is a string. And again, without any writing any implementation, just if you follow the convention, it will also make these methods available and it will execute a proper SQL query. But of course, you have to be careful what you expose over here so that you have proper indexes in the database. Okay. Do we have any questions? I guess we don't.
None. Yes, we could proceed. Yeah.
Okay. Okay. So now, now you've seen more or less like the same stuff we could do with REST, how we can do them with a GraphQL, just slightly in the different way with a different pros and cons. But GraphQL, and specifically maybe this implementation, has also some interesting features that you will not see in the regular, let's say, REST frameworks. We can add a field over here that will be called price. And this field is not really defined anywhere in the book type. And let's assume a hypothetical scenario that this price is just not persisted in the database. The price actually would come from external third-party service. We don't even need to create any sort of a DTO that will exactly have this field, but we can do something very different. Instead, we can create a method in the controller that will be called price so that it matches the field name in the schema. And it will take a book as an argument. We also have to annotate it with schema mapping. And just let's add a logger over here. Fetching price for book. And this should be enough to now be able to call a price. And of course, in our case, this is hard-coded. But the framework will just figure it out that we are fetching this field, or maybe differently. We are asking for books. It looks like, okay, so when we fetch the book from the database, all these fields except price are present over here. So it will try to search for another data fetcher for the price field on the book type. And when we add a method like that, annotated with a schema mapping, it actually registers this data fetcher. And since we have this book over here as a parameter, it knows that its parent type is a book. So now for each book that it found in the database, it will execute this method to fetch the book price. And I think this is really fantastic. So now the problem is, again, like every time we discover something that is cool, we also end up with an issue that for each book, it will execute this method, which again, potentially can result in an n+1 problem, depending on how we fetch the price for this book. And there is also a way to avoid it. So instead of calling this method for each books returned, we can make it, we can create something that is called batch mapping. And instead of taking one book, it will take a list of books as a parameter. Whoa, what have I done? Like this. And now, instead of returning just a string, it has to return a map of book to string. And string exists here just because I defined the price as a string. So now we could say that we have a, let's say, fetching prices for books. Let's not list them. And let's create a new map. This will be a map of book and string. And then for each book, we will, what are we going to do? This will be for each book. We do prices, put, and the key has to be a book. And then we put a different price. So of course, this is just a dummy example. Like normally, maybe you would go to some web service and fetch prices, all the prices in the just one batch, depending, of course, of the API offered by the service. But again, this gives us like a different ways to avoid n+1 in case our data source is not actually the database. So now if I call it again, this method will be obviously executed only once. Okay. So this was for fetching, so for queries. Oh, okay. And before we move to mutations, just one more thing. Like if you look at the actual HTTP request that was executed over here, you will see that whatever we invoke, whatever is our query, like no matter if we just fetch books, what fields we put. They all go always to one and the same endpoint, which will be /GraphQL. This is of course configurable, but the point is that there's just one endpoint for all your API interactions. No matter if it ends up with a problem like an error, let's say, with fetching some pieces of data, the HTTP status is also always 200. And the errors are displayed in a little bit different way. So let me go to book controller, and then instead of fetching these prices, let's throw new runtime exception. And then let's see how it will behave. So now, even though it returned an error, it's still 200. The framework is configured to hide the error detail. So it means that we will not leak some sensitive problems to the client. It only shows where the actual problem appeared. But what is quite cool, that even though there was an error with fetching this price, we were still able to fetch the rest of the data. So it will return a partial response with the data that was possible to be fetched, but the rest will be just set to null. So this is like a gradual degradation of a service, let's say. Okay, and so these were queries. So fetching the data from the API is one thing. The other thing is that we want to put some data in. So like in the REST world, we would call it post or put requests. In GraphQL, it is that it is a mutation. So queries are for fetching the data, mutations change the data. And for that, we have to also create a new type, mutation, that will have a list of all the mutations. So this, let's say we will call a method add a book, and as a parameter, it will take a book, and we have to define an input type, which will be a book input. So now input types have a special keyword. So it's an input, book input, and we follow pretty much the same way of defining the types. So we say that for when we add a book, we want to have an author ID, and we want to have a title. And we also want to have a publication year. Oh, and it has to be and now we have to say, what does it return? So let's say this returns a book. Okay, so now let's go back to the controller, and we have something that is called mutation mapping. Again, the names have to match. So this will be a book input. And the book input can be defined as a record. So this will be title, publication year. Maybe I can copy paste it from somewhere, or maybe I don't. And also an author ID. Okay, so now we can fetch the author. So we have to go to the author repository. And we can just, what can we do? We can find by ID. And let's do it in an ugly way. So we just fetch get. And then we create a book. And it will be new book where so first we take title, publication year, author. So now if we go back to this console, we should be able to invoke mutation. So now I can say that what fields I'm interested in. And now I have to provide the publication year, let's say 2020, title, and the author ID, which will be 1. Okay, so it says that this was parameter 0 was not recognized, and that's because I have to annotate it with what was it's an argument. Okay, so let me run it again. Okay, so mutations work in a similar way. We just pass the arguments, and also since mutation returns certain data type, we can define which fields we are interested in. So we have basically the sending the data and getting the data covered. One thing that GraphQL also offers is something that is called subscription. I will not show it today, but that's something that is potentially opens possibilities that were totally not really covered by the REST APIs. So it means that you can subscribe to a query, meaning that you define a query you want to be subscribed to, and whenever the result of this query changes in the backend, this data will be pushed from the backend to the client, which I find very, very interesting. Okay. And probably you can be wondering if this is all about GraphQL, and it's definitely not. We just scratched the surface. There are a lot of things that, first of all, GraphQL also offers, like if you dig into details, but also there are some interesting challenges when you develop GraphQL APIs that you have to take into considerations before you actually make a decision that you want to develop a GraphQL API. If you work with microservices, and I believe many of you do, usually these APIs are like REST APIs are scattered between multiple services, and then you have an API gateway that somehow acts as a proxy to all of these different services. And in our case, the books API could live in one service, the authors API could live in the other service, and just the API gateway just brings all of these endpoints together. So that from the client point of view, you are not really interested in which server it lives. But when you use GraphQL, one of the key points is that from the client side, you don't really care what is happening on the backend side. So from your point of view, you want to send a query to one single endpoint, and you don't care how this actually happens. So then it means that you have to have a infrastructure component that is able to combine the APIs, the GraphQL APIs from both of these services into something into one. And that's something that it's not covered out of the box by Spring for GraphQL, and I don't think it ever will. This is solved by something that is called either schema stitching, or there is also a component called GraphQL Federation developed by Apollo company. So you can create like a GraphQL Federation server, which is done with Node, that is able to get and merge the schemas from multiple services and present it as a single schema. Then, since we ditched everything that HTTP offers, we also ditched the HTTP caching. And the caching actually is very well standardized in HTTP. So it means that now we have to rely on some custom options on how to integrate caching. And depending on what GraphQL solution we take, the caching can be done differently. You can still do caching, of course, on the application side, like with Spring, with regular at cacheable annotations. But if you want to cache at the edge, like on the CDN or just, you know, on the proxy, then things become a little bit more tricky, especially because the post requests are usually not cached. I'm not saying that this is not possible, because this is, again, already a solved problem, but this is like a one extra challenge that you will have to solve, and you wouldn't have to solve if you just go with the regular REST API. And then we also have database transactions. Since there is no one single entry point to resolve the GraphQL query, there can be just like this multiple methods in your controller that take part into resolving GraphQL query. There's no natural place to put at transactional annotation. So you could theoretically create some sort of an interceptor that will create a transaction at the beginning of handling the request. But it also comes with certain challenges. And just officially, there is currently no support for @transactional in Spring for GraphQL. There's an open issue, and I believe this will be eventually solved either through providing this functionality or at least guiding on how to solve the transactions problem with GraphQL. But at least right now, this is not really the case. And since we just scratched the surface, and probably, I hope at least that you want to learn more about it, these are the links that you should go to if you want to dig deeper. GraphQL Java is a very special one, because this is the documentation for the library that lives under the hood of Spring for GraphQL. So this is actually the core of everything that is happening in the GraphQL execution. And Spring just takes this library and make it feel like a Spring, like gives the Spring programming model for GraphQL Java library. And How to GraphQL is a site with very nice tutorials. And then is my YouTube channel that it's not, maybe, I mean, you can take a look. It's not so many videos as probably you could imagine. But if you want to, let's say, follow stuff that I do with GraphQL, you can join me on Twitter. Thank you very much. This will be it. If you have any questions, feel free to ask, because I still have 6 minutes. And if you think you could, you have some questions later on, feel free to ask me on Twitter.
Great, Maciej. I think, that's a brilliant session. In fact, for most people, I think, you could say that most programmers are at some point guilty of overfetching, right? So typically it happens because you want to send something to the front end just in case. So you don't need to render that right now, just in case. It's a little bit of laziness, a little bit of ensuring against some future use case. You don't want to refactor code later. So whatever it is, this is something that happens quite a bit, but then a lot of it sometimes is unintentional, and you'll have to write your code in such a way as to send only selective things, and that's not easy for several programmers. So I think, what we've seen, it's really interesting to see how GraphQL solves that problem. And also, I've been impressed by the expressiveness of the code, because the absence of obviously those loops, and it's very expressive, and probably what you write, if something takes like about 10 lines in a typical REST API program using Spring Boot, I'm thinking, I'm assuming it should take fewer lines in GraphQL, right?
I mean, potentially. So, I mean, GraphQL solves some problems, but it also introduces new problems. And I would say that when you use GraphQL, it becomes a bigger problem for the backend developers than it used to be with REST. It's definitely much nicer to use on the front-end side, but then you have to just, there is a bigger responsibility on the backend. and there is of course a price for that.
Right, right. And I've got like 3 or 4 questions, and some of these questions are typically the questions that we get for more or less every session. So one is, people want to understand, if GraphQL is being used in any production use cases that you know of, any popular use cases that you can refer to.
Oh, GraphQL. Oh, it's super widely used. I mean, of course, not as much as REST, but I mean, first of all, the GraphQL originated from Facebook. So Facebook uses GraphQL. As far as I remember, Netflix also uses GraphQL. Expedia Group also use GraphQL.
Right. And
I don't know, but this is, I mean, this is not a new technology, right? And GraphQL was released like in 2015. It's just the Spring is very late to provide the official support for that. I would say it like that.
Right, right. And are there any performance implications to keep in mind when we're moving from REST to GraphQL?
Yeah, I mean, first of all, and the most common is, I guess, the N+1 problem. Either if it's on a database level or if it's like a fetching from some other APIs. So that's something that you definitely have to be aware of. And then it's also like since schema usually allows you to go like very deep, so you can fetch like really go very deep. For example, GitHub uses also, or at least it used GraphQL for their APIs. And you could say that I want to fetch all the repositories, and then for each of this repository, the owner data, and for each of this owner data, I want to fetch all the organizations that he belongs to, and then for these organizations, I want to fetch all the members. So you could create like a huge query that if it's gonna be executed on the backend, it would cause like hundreds, I don't know, I'm guessing like the bunch of requests that will be very costly. So you can also prevent it by setting like how many nested levels of a query you actually allow to be executed within a single query. So this is like how you can prevent clients from, let's say, abusing the API.
Right.
And I would like to add one more thing about these overfetching, because the overfetching is often the argument for using GraphQL, but often I think this is not a valid argument. So because the responses are usually gzipped, so when you fetch whatever, like with a REST API, you fetch anything from the backend, the response comes gzipped, and this is unzipped on the client side. Adding one field or two does not make a huge difference. It makes a big difference if these fields are either large, or if this is the case of the field that comes from a different service, right? So then you just by overfetching, you just cause more effort to be done on the backend that is actually needed.
Right. And the last question that I have is, they've seen some resources on the on the slide that you shared, and they're hoping that the slide deck will be available to participants after the session, right?
Yeah, I will definitely publish it, but I will do it probably tomorrow, not today.
Okay. So they're asking if there's like an official certification program that anybody runs that would help them
for GraphQL.
Yes.
I'm not aware of. I'm not saying there is none, but I would be surprised if there is something like that.
Okay. And so the other question is, I think this is slightly more technical. So essentially, REST philosophy is to have stateless APIs, right? Stateless transactions. So with GraphQL, is that still the case, or does it have to have more state?
No, not really. I mean, the only difference I can see is the subscription, right? Because this is a part of GraphQL, and you subscribe to an endpoint, and then this endpoint gives you, like, pushes a data to you. So you can say that there is let's say, the session created between the client and the server. But other than that, you can also use the similar authentication methods as you would use with normal REST API, and there is definitely no need for an HTTP session.
Right. And do you also see some of this coexisting with REST? I mean, both REST and GraphQL coexisting in implementations.
Well, I haven't seen it in practice. I know that this is definitely like when you start integrating GraphQL, you usually move it gradually. So you just move some of your API's functionality to GraphQL, and this is totally possible to be done with Spring, that you have both running at the same time. But this is not the end state that you want to have. Like you want to have either this or that.
Right. Got it. Because they more or less do the same thing. So you will need both.
Yeah, I mean, you can say that for some clients, it's better some clients are more interested in fetching using REST API, and some are for GraphQL. This is the case for GitHub, right? They offered the same functionality over REST and over GraphQL. But this is let's say a special case when you offer a public API. If you work in the regular company and you build an API that is consumed internally by the client that you probably know, then I guess you don't want to end up in this maintenance mess where you have to maintain 2 types of APIs.
Right. So cool. Yeah. So I think that's about it in terms of the questions that I have. But thanks a lot for a lovely session, Maciej. Very, very useful to a lot of programmers. And the similarities with the REST, I think, that should be something that helps with the uptake, because it isn't too different from REST in the end. So that's a cool thing. But thanks a lot for a great session, and we will try and get you back for another session sometime very soon.
Thanks a lot for having me. And if anyone would like to connect, to discuss, ask questions, definitely go to Twitter. Twitter is the easiest way to approach me.
Cool. Thanks a lot once again, Maciej.
Thank you.
Bye-bye.
Bye-bye.